alaikum wa rahmatullahi wa barakatuh. We will continue explaining Chapter 2, Geometry Looking Back, Part 3. At the end of this video, students will be able to recognize the properties of plane figures, admitting an axis or center of symmetry. Please prepare the following materials. Figures having axis or center of symmetry. Property. If the symmetric of a figure about an axis or a point is the figure itself, then we say that the figure has an axis of symmetry or center of symmetry. Example 1, segment. Look here, my lovely students. This is segment AB. This is the point M, the midpoint of segment AB. I will measure here the two segments AM and I will measure MB. Look here for the two segments. They are equal to each other, so we can set that the midpoint of the segment is the center of symmetry of this segment. You know that the center of symmetry, to draw a image of a figure by using a point or center of symmetry, you should take the same distances on both sides. Then we can set that the midpoint of a segment is the center of symmetry of this segment. Look here for this figure. This is segment AB. This is the perpendicular bisector. Perpendicular bisector divide the segment into two equal parts and making it perpendicular. This is the axis of symmetry. I will measure here the two distances here. AC. Look, it is 2.6, and I will measure CB. Also, it is 2.6. Then we can set that the perpendicular bisector is the axis of symmetry of the segment AB. The perpendicular bisector is an axis of symmetry of segment AB, since the figure before the perpendicular bisector is the same as the figure after the perpendicular bisector. Example 2, rectangle. Look here, my lovely students, for the rectangle. The rectangle has two axes of symmetry. They are the midlines. Look here for line MN. The figure here is the same as here, then MN, the midline, is an axis of symmetry. Also PQ. Look for this figure and this figure, they are the same, then PQ is an axis of symmetry. Center of symmetry is the point of intersection of the diagonals. I'll show you that. I will take any point on the rectangle. Example PI. Look for PI, it is 2.46. I will measure also IQ, it is 2.46. Then Q is the symmetric of P with respect to I. So I is the center of symmetry of the rectangle. Then, my lovely students, we can set that the point of intersection of the diagonals is a center of symmetry. The lines holding the midlines are axes of symmetry. The midlines are MN and PQ. It has two axes of symmetry. Example 3, square. Look here, my lovely students, for the square. The square has four axes of symmetry. The midlines, look here for this midline, EF. If we take EF, the figure here is like the figure here. Then EF is an axis of symmetry. GF, the second midline, also the diagonals AC and DB, they are an axis of symmetry. So it has four axes of symmetry. And one center of symmetry, which is O, the point of intersection of the diagonals. Also, I will show you, I will take any point, example A, and I will take O, ABC. Look here, AO and OC are the same measure, then we can say that C is the symmetric of A with respect to O, so O is the center of symmetry. And we can say that the point of intersection of the diagonals is a center of symmetry. It has 4 axes of symmetry: AC, BD, EF, and GH. Rhombus, my lovely students, it has 2 axes of symmetry. They are the diagonals. Look for line MP. The figure here is same as here, then it is an axis of symmetry. And also for LN, the figure here is the same as here, then it is an axis of symmetry. It has 1 center of symmetry, which is O. Then look, I will measure also for you LO and O, and they have of the same measure, then O is the center of symmetry of the rhombus. So the point of intersection of the diagonals is a center of symmetry. The lines holding the diagonals are the axes of symmetry. Parallelogram, my lovely students, has no axis of symmetry. It has only center of symmetry, which is I. And also I will show you that I will measure A, I, and I. See, look here, the 2 segments have the same measure, then we can say that I is the center of symmetry of the parallelogram. Any point, my students, you take it on the parallelogram and you make a symmetry for it with respect to I, then you will have the same measures on both sides. So the point of intersection of the diagonals is the center of symmetry. It has no axis of symmetry. Equilateral triangle. Equilateral triangle, my lovely students, has no center of symmetry. It has only 3 axes of symmetry, which are the bisectors of the angles. Look for BE. It is the bisector of angle ABC. Look for this figure, EAB and BCE. They are the same. And also CF, the bisector of angle C, and also AD, the bisector of angle A. So it has 3 axes of symmetry, the bisectors of the. Then it has 3 axes of symmetry, which are the bisectors of its angles, or the medians, or its sides, or heights, or the medians of its sides, or heights relative to the opposite sides. It has no center of symmetry. Circle. Look here for the circle. It has 1 center of symmetry, which is the center of the circle. I will take any point here on the circle and I will make symmetry, and then I will measure the distances. F prime, I will measure F, O, and O, F prime. You will see that the 2 segments have the same measure. Why? Since the radius in the circle is the same in all the circle. So O is the center of symmetry of the circle. Now, my students, to show if there is a axis of symmetry, I will take this line, any line that is passing through the center of the circle. Look for the half of this circle and the half of this circle. They are the same. Then any line passing through the center of the circle is an axis of symmetry. O is the center of symmetry. The line passing through the center is an axis of symmetry. It has an infinite axis of symmetry. Now, bisector. First of all, definition. The bisector is a semi-line that cuts the angle into 2 equal angles. This is angle A. This is the bisector of angle A. I will take a point on the first side of the angle and I will make symmetry to this point with respect to the bisector. The symmetry of this point is on the second side of the bisector. Then we can say the bisector is an axis of symmetry. I will measure here. I will match EF and I will take a point here and I will measure for you the angle look here, the angle is equal to 90 degree, then we can set the bisector of the angle is the axis of symmetry of this angle. So the bisector of an angle is an axis of symmetry of that angle. Application 1, draw all the lines of symmetry of these shapes. Please pause the video and try to solve the application. This figure has 4 axes of symmetry. This figure has 1 axis. This figure has 4 axes of symmetry, 1 axis of symmetry, 3 axes of symmetry, and 2 axes of symmetry. Application 2, answer by true or false. Please pause this video and try to solve the application. Solution: triangle that has more than 1 axis of symmetry is equilateral. True. A rectangle and the rhombus have the same number of axes of symmetry. True. They have 2 axes of symmetry. The square has only 2 axes of symmetry. False. It has 4 axes of symmetry. A circle has only 2 axes of symmetry. False. It has infinite axes of symmetry. This is your assignment. Summary: axial symmetry and central symmetry conserve distance, angle, measure, collinearity. Images of figures: image of a line is a line, image of a segment is a segment, image of a figure is a figure congruent to it. Figures: circle, infinite axis of symmetry, center of symmetry. Equilateral triangle, 3 axes of symmetry, no center of symmetry. Segment, perpendicular, bisector, midpoint. Angle, bisector, no center of symmetry. Rectangle, line holding the midlines 2, point of intersection of the diagonals. Rhombus, lines holding the diagonals, point of intersection of the diagonals. Square, 4 axes of symmetry, point of intersection of the diagonals. Parallelogram, no axis of symmetry, point of intersection of the diagonals.